We have Ahmed from South Africa to share a composed topic. But go ahead, I'll let you introduce your topic and a bit about yourself, and we'll get started.
Awesome. Thank you so much, Michael. And thank you to everyone, to the organizers. Thank you so much for having me. I truly appreciate it. I am all the way from South Africa. Yeah, so my talk is titled From XML to Compose, My Journey of Transforming an Existing Large App to Jetpack Compose. I'm Ahmed Tikiwa. I'm a senior software engineer in Android at a company called Luno. I am based in Cape Town in South Africa. And yeah, so let's get right to it. So the first question I guess you'd ask is why compose, right? And so most Android development, including my own, included defining layouts using at least one XML file. This XML file will then contain a tree of UI widgets constituting an Android view hierarchy. If the user interacts with the screen, for example, this would result in a change in the app state, and thus a need for the UI hierarchy to be updated to display the current data representing the changed state. However, to update the UI, a function such as find view by ID is used to go through the hierarchy tree, and then the internal state of the node, which is the UI widget, is updated through functions like set text or add child. This manual change of the UI widget is very error prone. For example, trying to set a value to a node that has already been removed from the UI, that's resulting in an unintended exception. The more views that are part of the application, the higher the level of maintenance and complexity. Jetpack Compose was created with the intent to simplify the above and instead accelerate the way in which we develop our UIs, using less code and benefiting from a list of powerful tools, all in Kotlin. In other words, there's no more XML defined views, which is referred to as the imperative approach. Rather, your views are now defined in Kotlin code, which is referred to as the declarative approach, meaning you now describe your UI. So, what are other companies saying about Compose? At Monzo, they're saying it's much easier to trace through code when it's all written in the same language, that language being Kotlin, and often the same file, rather than jumping back and forth between Kotlin and XML. At Twitter, they had this to say: our theming layer is vastly more intuitive and legible. We've been able to accomplish within a single Kotlin file what otherwise are extended across multiple XML files, which are responsible for attribute definitions and assignments via multiple layered theme overlays. So, when was Jetpack Compose introduced? I first heard about Jetpack Compose when it was announced as a preview by Google at I/O in 2019. And so, and at the time, this is what one of the engineers, the product managers actually at Google had to say about Compose. One of the areas we never solved was UI. We really wanted to look at how could you make it super simple to develop UI. This was Karen NG. And then Leela Richardson had this to say: what I think is once people start seeing Compose in action, it really becomes a delightful thing to program. So, like any developer or programmer, I was excited as I was already using Jetpack libraries extensively as part of my development, with a new one that was being added to further accelerate or speed up my development with even less code. Though I was excited, I was also trying to not feel overwhelmed at the prospect of learning a whole new way of writing UI, as the imperative approach is what I was used to for years. Due to time constraints, I also delayed learning Jetpack Compose until recently. So, learning Compose. I started learning Jetpack Compose through the course on the Android developers website, which takes you through step by step into understanding the inner workings of Compose, from thinking in Compose, the basics, navigation, theming, animation, integrating into existing apps, all this through articles, videos, and code labs. The course also has a short quiz at the end to test your understanding of Compose and includes a Jetpack Compose badge, which will be added to your developer profile on successful completion. In addition to this, as I'm a visual learner and with a desire to thoroughly understand Jetpack Compose, I went through 2 paid Jetpack Compose courses on Udemy. This approach is, of course, totally optional, but the extra visual tutorials helped me. The first was a short course by Katalin Gita titled Jetpack Compose Crash Course for Android with Kotlin. And then the second, which was a more extensive course by Paolo De, which covers the Kotlin fundamentals for those either who need a refresher or who are new to Kotlin, and a series of different apps to help solidify the compose concepts and how all the components fit together, coupled with state management. This course is called Android Jetpack Compose, the Comprehensive Bootcamp 2022. So, about the app. I created Up Next TV Series Manager in 2015 as a passion project of mine and has been in production since and available for download from the Google Play Store. The app is also now open source. It's officially part of the Google Developers Dev Library, which is basically a library featuring open source projects from around the world that make use of Google technologies. So my app is part of this official library. The app boasts the following screens: a dashboard screen showing a schedule of shows that aired the previous day, the current day, and the next day, provided by the TV Maze API. A search screen allowing the user to search for shows with the results displayed in a clickable list of cards with data provided by the TV Maze API. An explore screen, currently popular, trending, and most anticipated shows provided by the Trackit API. A show details screen showing a summary of the show, cast information, a rating breakdown from Trackit, previous and next episode information provided by TV Maze and Trackit APIs. Then there's a list of seasons for a particular show displayed in a list of clickable cards with data provided by the TV Maze API. Then there's a list of episodes for a particular season displayed in a list of clickable cards with data provided by the TV Maze API. Then finally, there is a Trackit account screen, which displays one of two screens, depending on whether the user is logged in to their Trackit account or not. If the user is logged in, their list is of up next favorited shows, which will be displayed. So, adopting Compose, choosing the right approach. What makes Jetpack Compose so powerful is that it caters not only to developers creating new apps, but also to developers who have existing apps and would like to include Compose into it. What makes the latter a possibility is the concept of interoperability. What this means is that Jetpack Compose code can live side by side with XML-based code. With that said, adoption can be done in one of two ways, according to the Android developers website. We start off with the bottom-up approach, which starts by migrating the smaller UI elements on the screen, like a button or a text view, followed by its view group elements until everything is converted to composable functions. Then we have the top-down approach, which starts by migrating the fragments or view containers like a frame layout, constraint layout, or recycler view, followed by the smaller UI elements on the screen. The reason interoperability is a possibility is because Google understands that overhauling an app can be very expensive. And so introducing Compose into an existing app should be done step by step over a period of time. Migrating an app to Compose takes time, and this is the case for my app, where there are still parts that need to be migrated to Compose, such as moving to Compose navigation. And so I will now show how I leverage the power of interoperability for every screen, where my approach was screen by screen, where I converted each screen layout to Jetpack Compose. So what does interoperability look like? Each of my fragments has an XML layout view associated with it. Some screens also have an additional layout view for recycler view items used by their respective recycler view adapter. And then as this is a gradual migration to Compose where I'm going screen by screen, I'll be completely removing fragment files in future and have Compose navigation where the navigation will be from composable screen to composable screen, as opposed to right now where it's fragment to fragment navigation. Then Compose View makes it possible to introduce Compose UI content into an existing XML layout. The Compose View acts as a container to host the Compose UI content, thus making it possible for Android views to coexist with Compose UI in the same file. So this is how, continuing on with interoperability, this is how my fragment now looks. So this is now the after, while I've added what is called the Compose view. I removed all the Android views, which are the text views, recycler views, nested scroll view, constraint layout, linear progress indicator, and then replaced them with the Compose view. Then once the app makes use of Compose navigation, then the need for Compose view will become redundant. So I can actually remove Compose view once I've moved over to Compose navigation. Then this is how my fragment looks. So using data binding, I reference the Compose view in order to set it up. So binding.composecontainer.apply. So I'm now referencing the Compose view inside my XML layout. Then according to the documentation, by default, whenever the view is detached from the window, Compose disposes of the composition. Compose UI view types such as Compose view and abstract Compose view use a view composition strategy that defines this behavior to ensure unintended behavior and ensure that compositions are disposed of automatically when not needed. Then set view composition strategy is required. Without this, my app crashed as I navigated between the composable screens. Then the set content takes in a composable function as a parameter. In this case, the theme definition, which is MDC theme, explained below, which also takes another composable function in this case, the composable screen, search screen. So MDC theme is actually part of a library which I added called the MDC theme adapter, which allows your app to still use your own material design that you've designed within the app. And so what it does is it takes that vanilla material design theming system that you've defined, and then transforms it into Jetpack Compose material design. So it's basically an adapter that creates all the files and classes that it actually needs for material design within Jetpack Compose. So it's quite a handy library. So breaking down the changes, going down with the search screen. So my focus on the search screen was the following. I want to update the search bar to be a composable. I want to update the search results list where I create a composable representing a single item and then displaying the list of these single result items or composables representing a search result item. Then I will then remove the recycler view adapter, its view holder, and item layout. Then, so this is how the search screen. So I created the search screen composable, which is a function annotated with @composable. However, you might ask, what is a composable? So Jetpack Compose is built around composable functions. And within these functions, you can define your app's UI programmatically by describing the UI of your app, how it should look, and also provide the data to be displayed. You therefore no longer have to focus on the process of the UI's construction, such as initializing an element, attaching it to a parent, and so on. So for my composables that represent an entire screen, so normally this would be, in the imperative approach, this would be a fragment. So you would create a list fragment or dashboard fragment, that type of thing. So I like to add screen as part of the name. And also notice that the composable function name begins with an uppercase. So this is the norm when it comes to naming your composables. So my composable there is search screen, which will represent the entire screen, the entire search screen. Then for dependency injection, I use Hilt in my app. And because my view models are Hilt view models, I can pass Hilt view model to allow my view model to be provided here. The Hilt view model call is part of the Hilt navigation compose dependency, which I added to my app. Then because the data in my view models is currently being returned as live data, I can transform that live data value into state using observe as state. Every time there will be a new value posted into live data, the return state will be updated, causing recomposition of every state.value usage. Then when I migrate my up next navigation to compose navigation, I will then use the scaffold layout, which automatically provides slots for the top bar, the bottom bar, and for now, a surface layout with a modifier as fuel max size to occupy the whole screen will suffice. Then composables can take a modifier, which is basically a companion object that can help you define properties such as padding or clickability and more for your composable. Modifiers are probably one of the most used things that you will encounter within Compose. They're very, very, very useful. Then the column composable arranges the composables contained inside it to be arranged vertically on the screen from top to bottom, as you can see in the image there. And so I want to add a linear progress indicator, but in order to ensure that the list does not jump or shift its position on the screen when the linear progress indicator is removed from the screen, because when stuff is loading on the screen, I want to show a linear progress indicator, and when stuff is not loading, then I don't want it to be displayed. So linear progress indicator, once you display it on top of the list, that way when it disappears, the list remains in its position. To achieve this, I use a box composable, which is the equivalent of a frame layout and the imperative approach. The box composable allows views to be on top of each other, as you can see in the image there. Then inside this box composable, I have my own custom composable, which I call search area. Then, as well as the linear progress indicator, which is also displayed if the loading state is true. So as you can see there, I'm using my condition there to decide whether to show this composable or not onto the screen. Then here, before I explain what's going on, one concept is very important when it comes to composables. There is the concept of state hoisting, which is the process of moving state all the way up to the caller, and that way it ensures that the composables are stateless as possible. If a composable has got state inside it, then it is stateful, and that is not recommended. So in my case, the caller is my screen, search screen, and the screen composables and the composables below it need to hoist the state up to it as much as possible. There are times when state hoisting isn't always possible. However, it's the best practice to make composables as stateless as possible. That way you can reuse them. That way you can test them. So my search area composable will represent the text field for entering the search query as well as the search results. It accepts three parameters: the search results list, two function arguments on text submit and on result click. These are events that the composable will respond to and hoist up the responsibility to the caller of search area to decide what to do with that event. So on text submit will be invoked when the users enter the search query. This event is hoisted up from the search form composable. Then on result click is an event invoked when the user clicks on the search result items. This event is hoisted up from search result list composable all the way to search screen. So here's what the search form composable I created looks like. So the the caller is on the left hand side there. So search form on text submit, then the right hand side defined that function or that composable. So it has a mutable state variable called search query state. And in order to ensure that the state survives the activity or process recreation using the saved instance state mechanism, I use remember savable. Now the user's query will be remembered in a state variable, and it will survive configuration changes. Search form composable makes use of a search input field composable, which is a composable I created as a simple wrapper function around the material outline text field, which I will show in the next slide. Then the state variable search query state is then used in the input field. Initially, the value will be empty because it is initialized to an empty string. Then when the user types a value, the onValue change event is invoked, and then the search query state value is updated and then remembered. So here's what my search input field composable looks like. So on the left-hand side is the implementation, and on the right-hand side is the how I've defined this composable. As you can see, it calls the material outline text field, passing it the input label, the value state, which is a mutable state variable of type string. And then when the outline text field on value change is invoked, then that event is passed up containing the new value of type string. State hoisting. My search result list composable takes two parameters, the list to be displayed and a function argument, which will be the onClick event containing the search result item. Then search results list then makes use of the lazy column, which is the equivalent of the recycler view, but more powerful under the hood. Also with this, there is no requirement for adapters, view holders, and so on. Lazy column and its other counterpart, lazy row, simply take a list and inside the lambda, which is referred to as the lazy item scope, and define which composable represents the column or row for that list, similar to when you would create an XML layout for a view holder. This time you create a composable that represents that column or row. In the previous slide where I showed the search screen composable, I didn't show the full implementation until I'd covered the above in order to make things clearer first. So this is the full call for the search area composable, where a list is passed to it. And then when the search area composable's onResultClick is invoked, search screen will then call the nav controller as part of Jetpack navigation library to navigate to the show details screen. So as you can see, the responsibility here is the search screen. Search screen is the one that decides what to do with the event that came from the child composables below it. So state goes down, events go up, unidirectional flow. So the fun part, the before and afters. So on the left-hand side is my search fragment. And so this is basically the imperative version of the search screen. And on the right-hand side, this is the composable version of that. So at the top there, I'm using a composable called search form, and then below it, search results list. Both these composables are contained within search screen, which I mentioned represents my entire screen. So search screen contains two composables, search form, search results list, and many other little composables inside it. Then dashboard fragment. This is how it looks on how it looked rather on the left-hand side, and this is how it looks on the right-hand side using Jetpack Compose. So as you can see, it uses a their composables there called shows row, and then shows row, which uses the lazy row composable, which I mentioned earlier is the counterpart to the lazy column. So lazy row allows me to be able to arrange my items from left to right in a scrollable list from left to right. And then I can reuse that row composable down on the shows airing today, and the same thing shows airing tomorrow. So I'm able to reuse the same composable over and over again. So being able to reuse composables is actually what is recommended, because then it means that your composables are stateless. They only have one source of truth. You can easily pass them around and so forth. Then on the left-hand side, this is my explore fragment using the imperative. This is how it looks using Jetpack Compose. So as you can see, it's similar to the dashboard screen, only in this case, I created, three separate composables. So the first one is trending shows row composable, which also uses lazy row similar to the dashboard screen. And then I have popular shows row, and then I've got most anticipated shows row. And all these use the lazy row, which allows me to have a list that scrolls from left to right on the screen. Then the show detail fragment, this is how it looked before using the imperative approach, and this is how it looks using Jetpack Compose. So on the screen there, and just a disclaimer, so the toolbar that you see there and the bottom app bar on the previous screens, those are still the imperative approach. It's the content that is contained between those components that are actually Jetpack Compose. I still need to migrate the toolbar there or the app bar to the Jetpack Compose version, as well as the bottom app bar. All of that is still in progress right now, and I'll get to that in a later slide. So on this particular screen there, you've got the backdrop image, and as well as the title, as well as whether it's running, ended, and so forth. So basically the status of that show. So all of that is represented inside a composable called backdrop and title. Then underneath it, I've got poster and metadata, which is basically the little poster there, and then the metadata information. When does it air, the genres, as well as attribution information. Then I'm using the text composable, which is part of Jetpack Compose, to just display the synopsis of the show. Then this is the show detail screen continued. So this is now below the synopsis there. So this is how it looked using the imperative approach, and this is how it looks using Jetpack Compose on the right-hand side. So I've got a composable called Show Detail Buttons, which represents those buttons that you see there, seasons and add favorite. And then I've got Show Cost List composable, which also uses lazy row because I want the cost list to be a scrollable list from left to right. And then I've got my previous episode information as well as next episode information, which will be below it. And each one is represented by previous episode composable and next episode composable, respectively. Then continuing on with the show detail fragment, how it looked on the left-hand side using the imperative approach, and how it looks right now using Jetpack Compose. So I've got my previous episode composable, which I mentioned in the previous slide. And then I created a composable called Track It Rating Summary, which basically represents that area there with the ratings there. So it's a combination of the linear progress indicator to show that progress of how many people rated it as a 10, as a 9, and an 8, and so forth. Then I'm using a simple text composable to display the overall score as well as the votes there. All that is contained within this widget, which I created called Track It Rating Summary. Seasons episodes fragment. So this is how it looked on the left-hand side using the imperative approach. And this is how it looks right now using Jetpack Compose. So this screen there uses the section heading text, which is a composable I created to basically try and create a uniform version of headings across the app. So I can just call section heading text on any composable and just pass it the text I needed to display. That way my headings are always standard. They look to do. Then show season episodes uses a lazy column, which is a composable that allows me to have my list displayed from top to bottom, displayed vertically. And then each composable inside show season episodes is represented using show season episode card. And that's the card that you see there that says season 5, episode 1, with the title there, the synopsis, and so forth. So that there is show season episode card. And then show season episodes displays those episode cards as a list on the screen using lazy column. Then this is how the Track It account fragment looked using the imperative approach. And this is how it looks now as a composable called Track It account screen. So inside of this, as you can see, I'm using section heading text, which I said I can use all over the app. And then favorites list is what is used there to represent the list of shows that you can see there, displayed as a grid. And this is actually possible using a composable called Lazy Vertical Grid, which is also part of Jetpack Compose. So that allows me to display my items in a grid format. And then each item within favorites list is list poster card composable, and that's each individual card that you see there represented by that composable. So what still needs to be updated? I still need to update the toolbar, as I mentioned previously. The bottom navigation bar, I want to transform it to be the Jetpack Compose navigation bar. I want to migrate to Compose navigation. In fact, I'm currently busy with that. It is a work in progress. There is a branch which you can check out if you want to see the progress, and I will share that in a little bit. Then I want to remove all the fragment files. So completely do away with fragments and now just use composables. And then I want to replace surface with scaffold. So this scaffold now will allow me to have the app bar, the bottom app bar, and so forth in my screen. So it provides those slots automatically. And then I want to replace observer state with mutable state. This is completely optional. There's nothing wrong with observer state. It is purely my own preference. I could actually continue using observer state if I want to. And then I would like to add animations to make the navigation between the screens beautiful, as well as the different transitions and so forth. And then I would like to add, most importantly, tests for my composables. So testing within Compose is different to how we are used to with the imperative approach. There's a whole new way of thinking when it comes to tests, and even a whole new way of thinking when it comes to writing composables. So, resources. The official Compose documentation, developer.android.com/jetpack/compose. Then you can find the Compose course, which I mentioned, which I did, on the developer.android.com website /courses/pathways/compose. Then when it comes to Compose layout basics, this is where you can find that. There's also a Google I/O video that has been released actually. I think it's called Compose Layout Basics. That is also available to watch as a video on demand. Then state hoisting, which I mentioned is one of the important concepts within Jetpack Compose. This is where you can find that information. And then I mentioned that up next is part of the Google Developers Dev Library. So the code is available as an open source project and part of the Google Developers Dev Library. So you can find it at that URL. Just click on the view on GitHub to actually see the code itself. And I am completely welcoming any contributions from the community. Just remember to read the README as well as the contribution guidelines for more information on how you'd like to contribute. I am Ahmed Tikiwa. I'm a senior software engineer in Android at Luna. And you can find me on Twitter at Ahmed_Tikiwa. Thank you.
Hey, thanks so much, Ahmed. Yeah, that was great. Hey, I did have a question for you. If you've got time, do you have time for questions, or what's your time frame like?
I have time for questions.
Okay. Yeah, I was interested in how the statefulness and the hoisting you're talking about, mainly around the topic that I've been looking at work called accessibility, and things such as screen readers or talkback. I know there are ways in the XML layout version for UI, you can specify like the order in which things are read, and you can, have it read before this element or after that element. Have you done much accessibility wise in terms of this kind of idea of specifying the order in which components could be read out loud to the user?
Huh, that's interesting. No, I've not actually explored that. I would believe the way that you would list your composables, so the way that in which you call them would actually dictate how these composables may be read out or interpreted on the screen. However, there might also be an aspect where if there are conditions for certain composables to display at a certain point in time, they will be excluded from composition. Because remember, so composables basically react on state, and the duty is to display data based on a certain state. So if you then say, I don't want this composable to be shown when the linear progress indicator is showing, for example, then it's going to be absent from that composition completely. Then other composables are then going to be shown. So as far as the ordering is concerned, I'm not sure. So my only guess is maybe the way in which you actually specify them to say composable 1, composable 2, composable 3, composable 4, and assuming that they might be called in that way, but recomposition might mess up the order. So yeah, I haven't looked into it, but That's my guess. I can look into it for you.
No, that's okay. Yeah, just one of the things that I'd be looking into when I go down this route.
Okay. All
Yeah,
right. Yeah. It sounds interesting.
yeah. And plus, with how new Compose is still, I mean, what is it? 1.2, I think, was released last week. I mean,
Yeah, the
these features
beta.
may still be in development or coming out soon as people run into these issues. Yeah.
Yeah. Yeah. So it's at I/O. They announced that it was the beta one. Yeah, I think either this week or sometime soon with the production release. And they did make some changes as well, to certain components. I think there were changes as well to lists. Um, yeah, which if this accessibility issue that you're encountering probably might be addressed within there. I'm not sure.
Okay. Yeah, very good. I see in the chat, John asked, do you have a link to your app code? Do you still need that link? I think it was on one of your previous slides.
Yes, it is. Let me just jump to it.
Which another
Come
question
on.
I have is, would you be able to share these slides after that we can post and add to the event page?
Yes,
Is that possible?
definitely.
Okay.
Yeah, have you put
Um,
the link in chat for your specific app, or is it part of the courses?
sorry, I didn't get that.
Is your app part of the courses, or is it just a separate app?
Oh no, it's just a separate app. So this is something I built as my own personal project in 2015. It is actually on the Google Play Store. So I have users who actually have been using this since 2015. And then last year, or rather, I think it was beginning of this year, I then made it into an open source project. So in addition to it being on the Play Store, you can look at the code. It is on GitHub, and so and then this project itself got accepted into the Google Developers Dev Library. So to get to it, you can just follow that URL there. So devlibrary.withgoogle.com, and you can just search for up next. There's a search option there, and yeah, you'll be able to find that. And then if you just click on Beyond GitHub, then you can go to my code there. Feel free to fork it, and if you'd like to contribute, or even if you just want to explore how I've written certain things that I've mentioned within here. And then I'm busy integrating a library called Compose Destinations by Rafael Costa. And so a work in progress. So there is a branch there that talks about that particular library being added. So you can also view that if you want to. So yes, the code is available on GitHub.
Is that similar to Jetpack navigation, the composed destinations, or is that a different paradigm?
So what actually happened is that if you're familiar with the way we have to write navigation in the imperative approach, where we have to create a navigation graph, and then it also has this nice visual within Android Studio where you can see your different things, and you kind of had to follow a similar thing. Actually, you do. You have to follow a similar pattern. Jetpack Compose. However, you don't have a visual anymore, but there is still that need for boilerplate to create all your navigation graph, or do you find your navigation graph? So Rafael Costa basically tried to eliminate that need for all this boilerplate, and instead all you have to do is just annotate your composables with at I think it's at nav graph or root graph or something like that. I'm not sure of the exact annotation right now. But basically, all your destinations, just annotate them, and then you can define their route. You can define certain parameters within that annotation, and it will automatically generate a navigation graph for you. So you don't have to do all the creation of navigation graph. It'll do it for you under the hood. So it uses Kotlin a KSP in order to generate all of that, which is actually, it's a really cool library. It's gotten really popular with 1,000 stars now on GitHub. Yeah.
Okay, cool. So that's another way to get outside of the XML development realm, right? Because normally
Yes.
you'd create that graph and you'd manage the XML file for all of the navigational pieces and transitions or passing data, things like that.
Yes. However, you still have to move away from the XML. So the Compose navigation, so basically the normal Compose navigation already calls you to move away from the XML-based layout. You have to define your composables inside a Kotlin file. You have to basically define everything about your different screens. So you're basically creating a navigation graph, but in Kotlin. You're not creating it in XML, but in Kotlin. So because we are still having to do that, Raphael was like, no, there should be an easier way. Why can't you just annotate your composables and then it will automatically add it to a navigation graph under the hood? So yes, we're already moving away from XML completely within Compose, which is the beauty of it. Because now you're now declaring things instead of imperatively approaching the way the UI is built.
Okay, very good.
Yeah.
Do we have any other questions, or do you have a link to that effort? Is that like private repo, or is that, you said it has
Oh,
about
no.
1,000 stars on GitHub, or
Yes.
that'd be interesting to look into.
I'm going to paste it here in the general chat. There we go.
Great, thank you so much.
Yeah, no worries. It's actually 1,100. It seems to be growing. I'm actually, I really won't be surprised if somehow one day this actually gets integrated into Compose because of its popularity. That maybe, hopefully, one day down the line, we won't have to define composables, the navigation graph, by defining a whole list of different composables and all of that within a Kotlin file, but just annotate your destinations. So yeah, you never know. Maybe one day it will be part of Compose.
Yeah.
So it uses, its main features are type-safe navigation arguments, simple but configurable navigation graph setup, navigating back with the result in a simple and type-safe way, getting navigation arguments from the safe state handle, useful in view models, and nav backstack entry in a type-safe way, and then navigation animations through integration with Accompanist navigation animation, and then bottom sheet screens through integration with Accompanist navigation material. There's easy deep linking to screens, and then all you can do with official Jetpack Compose navigation, but in a simple, safer way. That's what the main features are.
Yeah, that looks very interesting. Yep.
Yeah, it's really good. I've so far I've been in my integration journey now. I've been liking it, and one of the main reasons that I was actually had issues navigating between my screens when I was coming from a deep link. So I'm actually hoping that, because it actually says easy deep linking to screens. So that's one of the main reasons why I'm actually using it, because with Up Next, I basically, when the user needs to log into their Trackit account, it's actually handed over to Trackit using OAuth. So UpNext does not take your login details or anything like that. It passes you over to Trackit. Then Trackit does its thing and then sends back the user with an authentication to UpNext. So that journey there, I now need to handle that within Compose. So before it was an activity that would have an intent, and then that intent will then pass it over to a fragment. So now I need to recreate that journey within Compose, which is why all of this is still work in progress. Yeah.
Very good. Do we have any other questions before we go? I don't know if Levi or John, if you had anything, or are those in John's household?
Not from my side. I think the presentation was great. I don't know if you knew, Michael, but I'm part of the team that is trying to use Compose on the app, and so we started the same way, the same approach you said, Ahmed, where we're starting to migrating just one button in an XML and see how it goes, and if everything goes fine, we'll move on to different elements until we get like a whole view completely built and composed. So this is a cool project that we just started, and I think the presentation that you just gave was great. It was like right on the spot.
Oh, thank you so much, Levi. And
Yeah,
I take it your. Oh, sorry.
Oh, go ahead.
I was just going to ask you. I take it your app is quite huge. That's why you're doing components at a time, right?
Yeah, we're starting with a small elements. The main we got our own some issues. There are some classes written in Java, and I know Compose doesn't work with Kotlin with Java, and so there are a few steps that we need to take, before we move on to fully adopt Compose. But yeah.
Yes. I do not envy that transformation, man, from Java to Kotlin.
It's gonna be fun.
All the best. We had to do it at some point. I think probably about 2 years ago. Yeah, so we made so this is at work now. So we made the decision to completely move away from Java. We had a lot of files that were written in Java, so it was a whole exercise, quite extensive. And yeah, it was nice when finally the entire code base was in Kotlin. So we don't write a single line of Java anymore. It's completely Kotlin now. Yeah.
Oof, I envy that because yeah, it's gonna be a lot of work, but yeah, I look forward to it.
All the best, man.
Thank you.
All right. Yeah, John, I don't know if you had any questions, but I was interested in hearing from Google I/O how Compose and Wear OS were being combined, and how you have the opportunity to build the Wear OS apps using Compose. Probably in the Canary versions of Android Studio, I think, right now, but it is possible, and I think that's the way of the future for now.
Yeah. I also could be gonna be developing for Wear OS.
Okay.
I've been doing Wear OS for a year and a half.
You've been developing for a year and a half on Wear OS.
Yeah.
Oh, nice. Okay.
I can now, I'm allowed to say it's a fitness app. That's all I'm allowed to say.
Are you looking into Compose, John, for that app?
So I actually tried Compose about a year ago, and then I had to redo the thing because Compose wasn't ready yet. But I think they're about to try another one in Compose. So, a year later, I think it might be ready. But my contract ends next month, so.
I do have one.
Looks like
Sorry.
it's gonna be great.
I do have one question, Ahmed. Compose, and this is because I have some experience with Flutter, but I did realize that Compose is very similar to Flutter. Do Do you know anything about about the Flutter, or like how or why Compose is like Flutter, kind of like it?
So I don't know Flutter, or at least I haven't worked with Flutter. I know of Flutter. I think I've taken a quiz at one point in time at the actual language structure, so using Dart. But yeah, so in terms of knowing it in depth, no, I don't know. What I do know is that when it comes to Compose, right? What they realized is that there's a lot of there are a lot of issues when it comes to writing your code in XML, and it's actually can be, as I mentioned in a slide where you're saying that it could be error prone, because for you to, if you actually see a layout, visualize a layout using the XML approach, right? You've got a whole bunch of things on that screen, and that basically define what is called the UI tree. And within that tree, you've got a tree of UI widgets. So you might have your constraint layout as your outer container. Then the constraint layout would have a text view, and then it will have a button, and then maybe there's another text view. And so for you to target the text view that's at the bottom, you're going to have to traverse through the tree in order to get to that element, just so that you can actually change it. And so they actually saw the issues with regards to that, as well as even performance, because when you have nested elements within your XML, you can actually slow down the device. It's not going to be pleasant for the user. So they decided, no, we're not going to define our layouts like this. We're rather going to describe them. So if you say, okay, so at the top of my screen, I want a text element. Below it, I want a button. And then you can literally say that. That's how you define your UI. That's why Compose is so nice, because you declare that, okay, text, and then you call the text composable. Then you say button, and then that's it. So you literally can define the composables that you want to be displayed, and the order that you specify them, that's actually how they will be displayed on the screen. So you can obviously put them inside a column or a row and so forth. But the way you actually lay them out within your composable function, that's, you're already describing your UI. You're saying, this is my UI. And when I go and I read your code, I can say, oh, so at the top there you've got a text, and at the bottom you've got a button. I can easily see that because you've described your UI, and when you run the app, that's it's going to be. So it's really about performance, about writing our code better, writing it more efficiently, and much easier actually, because when you write it in Kotlin as well, because we're already writing Kotlin for the business logic of the app. So writing your UI now within Kotlin just makes it simpler, because now you don't have to switch between XML and Kotlin. You can write everything within Kotlin. So that was the intent with creating Compose. So I don't know whether maybe they took some inspiration from Flutter. I'm not sure. I'm not sure of the connection there. I know that with the intent behind Compose, it was really just to make our lives better in terms of how we actually write our apps.
Awesome. I do agree with your opinion. I think having it in a way that is just in one file and you write it all in Kotlin it's great. So yeah, I'm thumbs up for that one.
Yeah, awesome. I think even Twitter said the same thing, where in one of my slides, let me just get to it. Yeah, our theming layer is vastly more intuitive and legible.
Yeah.
We've been able to accomplish within a single Kotlin file what otherwise extended across multiple XML files, because you're literally jumping between the different XML files. And sometimes you don't even know, because if someone decided to write 3 different or 4 different XML layouts representing one screen, you don't know where each and everything is, because you're going to be jumping from XML to XML and then trying to say, okay, so this section here, where is that in the code? And then now you're now trying to look for that. Whereas if I tell you you can go into search screen composable, that's where all the code is for that search screen. And then granted, search screen will have little composables because that's what's recommended. So different composables representing different sections of the screen. You can easily just go into that file and be like, oh, so that's the search area. Okay. Oh, that's the search form. Oh, okay, cool. So I need to make tweaks in the search form. I just go there and do my thing. You can easily just do all of that. And because you know Kotlin, you can also easily just understand it. Whereas if you're not having to jump between XML files, which can be frustrating.
Gotcha.
So one more question, Ahmed, about perhaps state of the screen. For example, if you go to a new screen and it does a quick network fetch and it returns 3 pieces of data or 3 images, and I'd like those horizontal. But if the API call returns 10 images, I'd like to do those vertical. Do you have the opportunity to, I guess, dynamically or handle that kind of a situation in the UI?
Yeah, so you can just switch between column or row. And so obviously all the data, you need to manage it within the view model. So the view model will control where it will be your source of data, and it will be the source of state, because state essentially is a value that can change over time. So you will have your composable listening to the state, so listening to the view model and saying, hey, view model, do you have those images for me? And then you can basically, so if I can just find an example for you.
So at runtime, you can change what's happening visually, right?
Yes. Yeah. So like, yeah, let's say the list of images that you're referring to is called, in my case, it's search results list, right? And can then say if search results list of size is equal to 3, then I would then put a within that if, I would then say column composable, because then I want it displayed in a column from top to bottom. And then I would say else, and then I'd say row composable, and then I would pass that information there. So now it will know that based on the state, because remember, composables are always reacting to state. So if you define a state variable, it's going to react based on that, and it's then going to perform recomposition based on the change of that state. So it will know. So you are then saying, my state, I want it to behave in these 2 ways. I want it to either be a row or a column based on the size of the list. And you can do that. So you just say, if the list is 3, column, else row. So you can define it within the composable.
Okay. And if like the second item, maybe you already had your list from your first fetch, but if later like the second item in your list updates, do you have like a binding ID, or how do you have a handle to like an element in the list that's already displayed?
Oh, so you basically can define a key. Lazy row, for instance, or the lazy composables have got a key specification. So you basically pass in a list. Trying to see. So I don't have it in the slides that I show. Sorry. There we go. So lazy column. So as you can see where I say items and then list, and then I can say comma key, and then you pass a lambda, and then within that lambda you define the key, so the unique identifier for that list of data. So in this case, my list items are shows, and each one has got a unique ID. So I can then say my key is my ID. So it will monitor that ID alone. So that way, when changes happen, so let's say the position of that ID changes or the state of that ID changes, it doesn't recompose the entire list. It'll just know that I just need to update that particular item on its own based on the key that you've specified.
I see. Okay. Yeah, that's great.
Yeah.
Awesome.
All right. I don't know if there are any other questions today, but this is great. And we can share the recording and the slides if that's possible and share this with our community.
Let me just so I will try and find the link for my list, and then I'll email them to you, Michael.
Okay.
Yeah, I'm just not sure whether I put them on slide deck or which deck website. So I'm going to just look that up, and then I'll share them with you.
Okay. Yeah. Very nice.
Yeah.
Yeah. Thank you. Thank you so much, Ahmed, for your time today, and it's great information, very pertinent for Android development these days.
Yes, definitely. And thank you so much for accepting my my request, and having me as part of the meetup tonight. I truly appreciate it, and thank you for giving me the time and your ears. Thank you.
All right. Thank you. Thanks, everyone.
Thanks, Ahmed. Thank you.
All right.
Yes.
Bye.